We're back talking about the last main topic that we have to talk about before our huge start test. And this topic is about probability. And probability is where we're trying to figure out the chance of different events happening. And this means predicting, right? So if I toss a coin, I can predict that it's either going to be heads or tails. Here we have different cubes. And I've got 4 cubes that are orange. I have 2 cubes that are yellow, 2 that are blue, 2 green, and 2 pink. Altogether, that's 12 cubes. And if I were to put them in a bag, I could shake it up and see, figure out what our chances are of getting, say, a yellow cube. Now, we have to be careful about our bag. It can't be a clear bag. Clear bags don't count because you can see right through them. That is not fair, right? We like to talk about fair, especially in, when we want things to be equal. We need something that we can put them in that won't be see-through, so that when we do our test, when we test this out and see what are the chances of getting, say, like we said, a yellow, if I put all of these in here, there's 12 of them, 12 cubes, that was 4, 6, 8, 10, and 2 more makes 12. So if I took and I shook this up real good, right, and I wasn't trying to not cheat or anything like that, and I went and I reached in without looking and I pulled something out. Oh, it's blue. Okay, blue. There you go. You can see the reflection there. It's blue. Okay, so this would be a more fair game. Now, really, to be a really good fair game, I would want to have something like a black bag or something that I really, really can't see through. So a fair game. Fair game is when you have all the events. That means every single cube. That's what that means. Every single cube had an equal chance of happening. So each event, we call it event. Every time you do something, it's called an event. Every time I pull out a cube, that's one event. So each one of those cubes has the same chance of being pulled out when I have my, well, we call this opaque. I can't really see all the way through compared to my clear bag, okay?
May I have your attention, please?
And it's full of cubes, and I've got, like I said, I've got 12 cubes in here. Okay, haven't pulled any out, anything like that. All right, and we want to write this probability as a ratio, but we want it in the fraction form. So we're going to put the part, and we're going to have the total number of events. So for us, we had 12 cubes, so I could pull out 12 different things, right? I have 12 possibilities. All right, so I want to know what part. Here, probability, I want to know what the probability of getting a pink cube is. All right, so there were 2 pink cubes, and I'm going to put this in my lovely pinkish color. There were 2 cubes that were pink, and we said there's a total of 12. Remember, if something's in fraction form, we always simplify. Not sometimes, but always. So we divide by 2. We have 1 out of 6 chance. That means if I did this 6 times, I should be able to get a pink out at least once. Now, is that going to happen? No, not necessarily. And it also depends. Do I put the cubes back in? So if I were to take the cube out, oh, no, that's orange, okay? If I were to take it out and put it back in, again, we have 12, again, I have to put it back in. If I take it out, that would mean that there would be 11 chances, so the math would change. So I'm going to put this back in. If I were to shake it up and try to pull out something without looking, oh, no, that's blue, okay? Well, I haven't pulled out a pink one yet. We're just reaching in. Oh, there's another orange. That's 3 things, 3 times I've tried. Let's see, how about that one? Oh, that looks like another blue. Well, I'm not having any luck here at all, okay? How many is it, 6? Oh, finally, guess what? I got a pink cube. Now that could have happened. Something else might have happened too. All right, but I should, according to probability, get 1 out of 6 chance of getting a pink cube. Every time I take 1 out, but then I put it back in, I have 1 out of 6 chance. That's probability. Okay. Look, what if I was not looking for my 1 out of 6, but what if I was going to throw this dice? Okay, this die has 6 sides. It's a regular die, like you've seen before other places. What if I was going to take this and throw it? If I throw it, I want to know what's the chance of getting a 5. There's a 5. Okay. Well, how many different possibilities are there? Well, we know that there should be 1, and it goes all the way to 6, right? So I want to know what the chance of getting a 5 is. Well, I've only got 1 5 on this die. I'm going to put it right there so that you can see I didn't. 1 out of, right, there's 1 5 out of 6 possibilities. So 1 out of 6 chance of getting a 5 on this cube. All right? Okay. Now, what if I wanted to know something else? What if I wanted to get a possibility of getting a 2 or a 3? Well, how many 2s are there and how many 3s? Well, there's a 2 right there and there's a 3. So if I throw this, okay, throw it hard, not just drop it, no cheating, okay? And if it's fair, then I have, well, there's 2 things I could get. I could get a 2 or I could get a 3, right? Those are 2 different things, 2 or a 3. That's 2 out of, again, we have 6 sides. Okay, so I'm going to simplify that. I have a 1 out of 3 chance of getting either a 2 or a 3. So if I threw this, I have a 1 out of 3 chance of getting one of these 2. Okay, there you go.